We're able to actually decode just from the nerve itself what the hand is doing and create a biologically accurate hand virtually. All the fine digit movements, flexions and extensions. This is a hard problem. And I think it's impressive. What you'll see next is how we actually do something more complicated. What you're seeing here is my intention. I'm not moving, but the nerve is active. And I'm just trying to wave my hand back and forth without moving. Here I'm showing the forces that I'm able to generate. This is just a simple grasp. And I actually have nice control over this. I could probably generate a number accurately between about 0 and 200. We're imagining what it's like now to take your hand virtually into VR. There's no cameras involved here. This is an always available you. Of course, the problem you're going to want to solve next is textual interactions, not just these sort of interactions that would be broadly based on moving your hands around. And this is work we did last fall. It's quite a bit further now, but this is me trying to type with some amount of spell correction, just kind of typing in the air, you'll see the device pop up on my arm here, and this is all your interface belong to us. And this is the future. It gets crazier. I want to show you neurocontrol. So neurocontrol is no longer about you moving, it's about you not moving. This is my co-founder, Patrick Kaifosh, playing Asteroids on a phone. Asteroids in the arcade took 2 hands. I wish we had the sound on right now because it's actually kind of fun, but the point is he has incredibly fine continuous control over asteroids, 2.5 degrees of freedom. Very fine control out of 1 hand, and he's not moving at all. You'll have to take my word for it. There's a device on his arm there. And what's crazy is he can train this in less than 60 seconds. De novo training. So this is continuous married to discrete degrees of freedom. Further, this is one of our lead scientists, Adam, who's going to show you how we map this to crazy things like a 7-degree of freedom arm. He's going to do some slight motions, which he's mapped to certain things, and then other things are based on things that are happening in an ulnar muscle, a residual from the ulnar nerve. And he's controlling this thing that you couldn't actually just map to your arm. It's got a wrist that can go 360 degrees. You would never be able to do that. All right. I want you to imagine where we see this going along with me. So yeah, you can play with 7-degree of freedom arms, but there's no reason why this wouldn't become the default interface for all of your interactions in the world. Finally, you can stop correcting the autocorrector. Just look at your phone and use it as the output device, which is really all it's good for anyways, and type on it, or do any kind of interaction. Play Asteroids. Don't swipe on it. We imagine this device being something that's always on and always available for you. It's the universal controller, or rather, you are the universal controller.